Hi everyone, this is your math guru. In this video, I'm going to show you how to solve the following analytical geometry question. We have in the diagram below the point A, -2 and 4, B, -2, -1, and C, P, -4 are the vertices of triangle ABC. Q is the x-intercept of the line AC. Theta is the angle of inclination of AC, and angle BAC is equal to 37 degrees. The first part of the question says, determine the size of angle theta. To find theta, I'm going to use the triangle highlighted below, such that I know that the value of angle theta, using the properties of geometry, which says that the external angle of a triangle is equal to the sum of the two opposite interior angles. And note that if you look at the coordinates of A and the coordinates of B, they both have the same x-axis value, which is -2. So what that implies is that the line AB is parallel to the y-axis, such that the angle formed will be 90 degrees. So therefore, to find theta, theta will be equal to 37 degrees plus 90 degrees, and the reason being external angle of a triangle. Therefore, the value of theta equals 127 degrees. Let's go to the second part of the question, which states that calculate the equation of the line AC. We have the line AC given. I'm going to highlight that. And because we've been able to find the value of theta, that's 127 degrees, using the standard equation of a line, we have that as y equals mx plus c, where your m is the gradient and your c is your y-intercept. Now, because we know the angle of inclination, we're going to use that. This says that tan theta equals to the gradient of the line AC. We got theta as 127 degrees, so I have tan of 127 degrees equals the gradient of the line AC. Therefore, MAC is equal to, if I punch in the tan of 127 degrees, going to give me -1.33 to 2 decimal places. So therefore, my equation becomes y equals -1.33x plus c. The next step is to find the y-intercept, which is the value of c. Note that to find c, we just need to pick a point on that line. In this case, I'm going to use the point A, such that I'm going to substitute the point A into the equation in order to get the value of c. So that's -2 and 4. So this would be my x value, and this would be my y. So if I substitute that, I have 4 equals -1.33 multiplied x, which is -2, plus c. I have 4 equals 2.66 plus c. Therefore, the value of c equals 4 minus 2.66. And my answer will be 1.34. Therefore, to write my standard equation, I have, therefore, my y equals -1.33x plus my c, which is now 1.34. The next question says, calculate the coordinates of Q, the x-intercept of AC. So therefore, note that at Q, the value of y, because that's the x-intercept, is equal to 0. So therefore, because I know the equation of the line AC, I'm going to use that. The equation of the line from my previous calculation is y equals -1 point or 1.33, depending on where you're watching from, the point and the comma means the same, that's the decimal point, plus 1.34. So therefore, because at that point the value of y is 0, I'm going to replace my y with 0. So I have 0 equals negative 1.33x plus 1.34. So I'm going to solve for x. From there, I have 1.33x equals 1.34. Therefore, dividing both sides by 1.33 or 1.33 is cancelled out. Therefore, my x is equal to 1. Therefore, because I'm to find the coordinate of q, my q will be x value 1 and my y value 0. The next question says, determine the integral value of p if the points A, Q, C are collinear. Collinear points are points that lie on the same line. And note that I was able to find the equation of that line. That's y equals negative 1.33x plus 1.34. Therefore, I'm going to substitute C, which I have the y value, which is negative 4. So I have at C, y equals to negative 4. So putting that back into the equation of that line, I have negative 4 equals negative 1.33x plus 1.34. Then I have positive 1.33x is equal to 1.34 plus 4. Therefore, that's going to give me 5.34. Therefore, dividing both sides by 1.33 in order to find the value of x, I have 1.33 divided by 1.33, that's 1. Therefore, x is equal to 5.34 divided by 1.33. I have that as 4.02. Therefore, my x value is the same as my p, which is equal to 4, because the question says I need the integral value of p. So p is 4. So I have the points C to be 4 and negative 4. The last part of the question says, determine the equation of the line parallel to BC and passing through the point A. Please don't forget to click on the like and subscribe button below for more easy to understand math concepts. So to give you a rough idea, a line that is parallel to BC and passing through point A, I'm going to draw a rough sketch as shown, such that I have that line parallel to BC. And we know that if we have two lines that are parallel to each other, what it means is the gradient of those two lines will be the same. So to start with the gradient of that line, I need to find the gradient of the line BC. So I have MBC is equal to the change in y divided by the change in x. I have my points B. Point B is negative 2, negative 1, and my point C, I have that as 4 and negative 4. So slotting that back into my equation, I have MBC equals negative 4 minus negative 1, I'm going to use my bracket, divided by 4 minus negative 2. And that will give me negative 4 plus 1 divided by 4 plus 2. Therefore, my MBC, or the gradient of BC, will be negative 3 divided by 6, which is negative 1 over 2. So therefore, I have the line in question is parallel to BC, so which is they have the same gradient, which is negative 1 over 2. So therefore, I'm going to rewrite that equation of the line, which is now being using my standard equation. I have two methods. I can use the intercept method or the standard equation of a line. The first one, y equals mx plus c, which is y equals my gradient, negative 1 over 2x plus c. The next point is, or the next step, is to find the value of c. Note that we've been told that it passes through the point A. So what I'm going to do is to substitute A, and the coordinates of A is negative 2 and 4. So therefore I have 4 equals minus 1 over 2 multiplying negative 2 plus c. I have my 4 equals positive 1 plus c, therefore c equals 4 minus 1, which is 3. So the equation of that line, y, therefore y equals the gradient, negative half x plus 3. Note that if I use the other method, so I have my method 2, I have the formula y minus y1 equals the gradient x minus x1, where y1 and x1 are the points on that line. So if I substitute that sub a, which is negative 2, 4, I'm going to have the same thing, which is y minus 4 equals the gradient negative half x minus 2, close bracket. If I simplify further, I have that as y minus 4 equals, I'm going to have minus 1 over 2 x plus 2, and if I expand my bracket, I have y minus 4 equals minus half x, then I have negative 1 minus 1, making y the subject of formula. I have y equals minus half x minus 1 plus 4. Therefore, I have y equals negative half of x plus 3. So note that using different method, I've been able to get the same value for the equation of the line that is parallel to BC and passing through point A. Thanks for watching. Bye.